Testing and monitoring for snowboard cross. Maximizing athletic development should be based on an informed decision making from integrated planning. At the center of integrated planning are suitable testing and monitoring strategies that are feasible and easily interpreted by relevant stakeholders. That's from Compton in 2019. So today I'm going to present to you a monitoring strategy that has been developed for snowboard cross riding. Now, it must be highlighted that snowboard cross is relatively untouched in terms of research. So I've drawn a lot of research from a number of different other sports, but mainly a lot of research from alpine ski racing, ski cross, mogul skiing, as well as a bunch of other sports. But today we're going to be going through the 5 strength qualities that were presented by James et al. In 2023 or 2023, and breaking them down into valid tests, measurements, and monitoring strategies that are the relevance, the validity, the reliability, the sensitivity, and the feasibility of each of the tests. And then we're going to go through a bit of a testing schedule that I presented for a snowboard cross rider. We're going to have a chat around load quantification at the end, and then we're going to have a little reflection on the semester. So before any more, let's get into it. So heavy dynamic strength is measured using repetition maximum testing, most commonly, as presented by James 2023. The suitability of the test is underpinned by feasibility. Without the constraint of feasibility, there wouldn't be any reason not to use the most valid, reliable, or sensitive tests that are available. However, I guess that applies to almost absolutely everything in terms of testing. So RM testing is cheap, it's efficient, it can be blended into a training session, which prevents athletes from missing out on other training sessions or having to do anything special. And as I mentioned earlier, it is valid. There's an intracast correlation of 0.94, which is obviously quite high, as presented by Matzak 2000 in 2003. As the test is valid, it shows that the measure is intending to show what it wants to show. Although it's simple and useful, the test isn't without its flaws, especially when testing in large groups of athletes or those with less lifting experience. It's obviously, as we've said, it's shown to determine changes in performance. However, there might be a better alternative, which is velocity-based training, which can be a little bit safer, especially in large groups. So we don't have to actually go for a 1RM or a 3RM. We can go for a 5RM and then measure how slow those reps are coming down, and then measure that over time. And then we can get a good understanding of what our heavy maximum dynamic strength is over time. So that could be a tool that could be used for larger teams instead. Obviously, with snowboarding, that isn't always the case, although sometimes we are testing teams or large groups of people. Moving on to isometric strength and explosive strength, maximal isometric strength and explosive strength. So I've kind of paired these two together because they do use the same test in order to do it. In terms of isometric strength, the sport-related metrics to this being interpreted are peak force and absolute force. So common assessments usually use the mid-thigh pull and the isometric squat. However, in relation to snowboard cross riding, especially in explosive strength, we would probably be using something to do with more of an upper body. It would relate more to a start gate pull. To my knowledge and to the research of the knowledge, there isn't any valid or reliable tests that are going to be good for explosive strength on the upper body. So that's something that can be looked into a little bit more, especially from a pulling position. Even though that there are ways to train it, I'm not really sure of the ways that we can validly test it to the level that we can for a mid-thigh pull and an isometric squat. There are alternatives that can be used. Obviously, having force plates isn't feasible for everyone due to budget constraints, although that is what we're going to need to use to find out all of the testing metrics within there. Some other measures that have been used and tested, and some of these are actually being tested for skiers, manual muscle test, which is essentially someone holding a scale or a special scale on a leg for a single limb to be able to move it. The only problem is it isn't a true isometric. You can't really justify the bar or the tester not moving completely. It does tend to end up having a slight little bit of a muscle contraction within it. Although the ICC values are quite high from inter-test relying. The other one is crane scales. So it's just like what it sounds like, a crane scale or a luggage scale that you can pull on. Once again, it actually shows that it's quite a reliable test, but the only problem is that it only shows force in Newton. So it's only a single factor that it's showing us. And as we know with our testing, that we're not looking just for the single force. We want to see all of the other metrics that come along with force platforms, like shown in this image here. So that is about it on that one. Moving forward into fast dynamic strength, regularly used to determine changes in strength and power qualities of the lower body and can give an indication of an athlete's fast dynamic strength. That's also from James 2023. Although the common metrics determined by the counter movement jumper usually jump height, peak power, and peak velocity, for the sensitivity purposes and the outcome of training measures for snowboard cross riding, counter movement jump would actually or could actually be used as a mean of measuring eccentric strength. Due to the nature of snowboard cross riding, we're essentially falling down a hill the whole entire time, trying to make up the displacement of body mass. So through measuring eccentric strength, we might be able to get some better, more accurate performance metrics towards the performance of the sport. And then moving on to reactive strength. So reactive strength really isn't shown so much in the performance of snowboard cross riding. There's not really any stretch shortening cycles that are occurring within races. Obviously, with our reactive strength, we're looking at measuring and contact times of under 0.25 seconds. So even in alpine skiing, turns are actually happening over about 4 seconds. And in snowboard cross riding, there's no stretch shortening cycle. As I mentioned, we're not really jumping as per, even though we may be landing. There could be some more research to go within it, but from this standpoint so far, it doesn't seem like there's anything to do with it. Although there could be some really good uses for injury assessment. There was a study done by Rashner in 2012 that looked at ACL injuries and drop jumps. So from a 40 centimeter drop jump, they found that those that performed better had a lower chance of injury. So furthermore, drop jumping is highly sensitive because Moran showed in 2023 that after performing 250 jumps per week over 7 weeks that the test improved. So it is highly sensitive, however, not very valid towards snowboard cross riding. So moving forward, losing my mouse here. There we go. Oh. Moving forward into our testing schedules. So we've got a couple of testing schedules here. We're looking at an unlimited budget here. We're basically going completely out with force decks, linear bar transducers, with weight plates, lots of use of the force decks there. When we would use them, I like to try and get a lot of these tests to be folded in within the season. So using heavy maximum dynamic strength with linear transducers, we can actually just get a reliable measure throughout the season for that. However, if we want to go into some actual testing batteries, we can do that there as well. there are staff that are going to be needed to be able to run these, but obviously if we've got an unlimited budget, we can go for it. If we're looking at a limited budget, I think one of the best ways to actually limit your budget is to take away your staff. And obviously you're not going to have the big force plate measures as well, but there's no point in testing things that we really don't need to test for performance metrics of snowboard cross riding if we are on a limited budget. If we're on a limited budget, we're probably on a limited time constraint for the athletes as well. So we can get a lot of data just from our heavy maximum dynamic strength, our maximum isometric strength, using a crane scale potentially just to get a metric of what our absolute strength and absolute force is there. Heavy maximum dynamic strength, once again, we could be using with velocity-based training through one of your phone apps, which is much cheaper. And then fast dynamic strength, we could use a counter movement jump as well and just sort of get some data from the jump height there as well. However, maximum strength has been identified as one of the most contributing factors to performance in snowboard cross riding. So if we go and look down at our monitoring schedule now, the monitoring schedule is going to be weekly through on an unlimited budget, weekly through your strength testing using gym-aware linear transducers. Then we can look at some isometric strength and explosive strength measurements using the Snowboard for hamstrings. This can be a little good use for injury prevention tools. Your fast dynamic strength, we'd try and use flat force platforms on that. That one I'd probably look at like once a month. We don't really need to be looking at it weekly. We want to make sure that we've got enough time within there for adaptation. And then the reactive strength, even on an unlimited budget, we are going to test it in the testing schedule. We don't really need to be following up on it all week, every week throughout the season. In terms of load quantification, load quantification is an integral factor to the strength of the coach's role in managing athlete performance. It allows the coach to monitor the difference between planned and actual training, differentiate between periodized phases in the athlete's plan, as well as management of the athlete's fitness and fatigue, which is crucial data required by the stakeholders associated with any given athlete. If feasibility factors weren't a constraint, research tends to suggest that superior methods for consider as the most variables as total workload. So that is highlighted over here in yellow. So that's using both linear position transducer and force tracking at the same time, so we can get a really good overall holistic view of the amount of work that's been done. If we did need to use a constraint, I think using a maximal dynamic strength volume load method is going to be the best for us there.
Always like to play with.
So that kind of brings me through to the end part of the presentation, where I just want to have a little touch on how the semester was. Got a little tiny video here that we can go through.
Always like to play with fire. Play with fire. Play with fire. Fire, fire. I've always liked to play with fire. Always like to play with fire. Play with fire. Play with fire. Fire, fire. I've always liked to play with fire. Always like to play with fire. Fire. Fire.
business. And
Always like to play with fire.
Also
always like to play with fire.